total productive maintenance is a system defined by Nakajima in 1988 in Japan, which informs on the life cycle of equipment used in different departments of organizations. Total productive maintenance is used to maximize efficiency and effectiveness, as its main aim is to maintain equipment in optimum condition to prevent unexpected breakdowns and other consequences of poor maintenance, such as quality defects and speed loss, to make sure all equipment can be used continuously to create a greater gain of every individual equipment. Total productive maintenance is aiming to reduce the 6 significant losses which occur when continuous maintenance isn't provided on equipment. The first of the 6 significant losses is equipment failing to work, resulting in unexpected loss of time. The second significant loss is commissioning and downtime results in losses during new operations. The third is minor failures and halting of production during regular day-to-day tasks cause greater downtime and therefore more losses towards the organization. The fourth significant loss is that operation speeds become reduced due to equipment not being properly maintained, and therefore this leads to a production loss as the desired speed is not achieved, therefore causing a loss towards the business. The fifth significant loss is the loss of time due to stations being idle because, for example, new products are being made or new processes are being implemented to create a more efficient business. Therefore, this is why total productive maintenance is used to stop all these 6 significant losses towards the business. The first 5S of the 5 S's is sort. Sort eliminates unnecessary equipment and materials in the workplace. The second S of the 5 S's is straighten, and straighten tries to organize the remaining items to maintain and define clean locations for materials, machines and tools. The third S of 5 S's is shine, and it deals in the implementation of cleaning practices regularly. It segregates various cleaning areas and assigns a team to every one of them for inspection. The fourth S of the 5 S's is standardize. It has been put forward to create standards for the activities mentioned above. The fifth S of the 5 S's is to sustain, and the objective of sustaining is to ensure the application of all standards makes the application of all standards constantly reinforced, keeping the business sustainable and carrying on in the future to create a successful organization.
What are the pillars of total productive maintenance? Firstly, you have autonomous maintenance. Autonomous maintenance means ensuring your operators are fully trained on routine maintenance like cleaning, lubricating and inspecting, as well as placing that responsibility solely in their hands. This gives machine operators a feeling of ownership of their equipment and increases their knowledge of a particular piece of equipment. It also guarantees the machine is always clean and lubricated, helps identify issues before they become failures, and frees up machine staff for higher level tasks. Focused improvement looks at the process as a whole and brainstorms ideas for how to improve it, getting small teams in the mindset of proactively working together to implement regular incremental improvements to a process. Planned maintenance involves studying metrics like failure rate and historical downtime, and then scheduling maintenance tasks based around these predicted failure or downtime. Because there are specific times to perform maintenance, you can schedule it around times when people are most idle and not using the device. The biggest benefit of quality maintenance is it prevents defective products from moving down the line, which could lead to a lot of rework. With targeted quality maintenance, quality issues are addressed and permanent countermeasures are put in place, minimizing or completely eliminating defects and downtime related to defective products. The TPM pillar of early equipment management takes the particular knowledge and overall understandings of manufacturing equipment acquired through total productive maintenance and uses it to improve the design of the new equipment. Designing equipment with the input of people who use it most allows suppliers to improve maintainability and the way in which the machine operates in future designs. Lack of knowledge about equipment can derail a TPM program. Training and education applies to operator managers and maintenance personnel. They are intended to ensure everyone is on the same page with the TPM process and to address any knowledge gaps so TPM goals are achievable. This is when operators learn skills to proactively maintain equipment and identify emerging problems. An example of this would be maintenance teams learning how to implement and proactively prevent maintenance schedules. Maintaining a safe working environment means employees can perform their tasks in a safe place without health risks. It's important to produce an environment that makes production more efficient, but it should not be at the risk of employees' safety and health. To achieve this, any solutions introduced in the TPM process should always consider safety and health and the environment. A good TPM program is only as good as the sum of its parts. Total productive maintenance should look beyond the plant floor by addressing and eliminating areas of waste in administration functions. This means supporting production of improving things like order processing, procurement, and scheduling. Administration functions are often the first step in the entire manufacturing process, so it's important that they are streamlined and waste-free. For example, if order processing procedures become more streamlined, then material gets to the plant floor quicker and with fewer errors, eliminating potential downtime while missing parts are tracked down.
Benefits and drawbacks of total productive maintenance. There are many benefits to total productive maintenance. However, there are also drawbacks to it as well. The first benefit of TPM is increased availability of equipment. This is done by the workers and operators gathering information about any downtime in order to predict failure and cause for it, which then can be stopped to increase availability. The second benefit is the increase in performance of the machines. This is done by making regular inspections and identifying any poor performance and the cause of it. Then on to the drawbacks, because that is very time consuming, meaning that it is hard to implement it into a business and make it run. The second drawback is that it's a very expensive method and not many businesses or companies are able to afford and implement this program into their business. There are also some other benefits within total productive maintenance. The next benefit is low manufacturing costs. As the OEE or overall equipment efficiency increases, there is a decrease in production costs. It is a fact that high productivity levels equal to greater profits. The next benefit is there is a high confidence level within the staff members and the operators. How to apply TPM into your workplace. A 5-step guide. The first step, identify the pilot area. The best way to implement this is not by introducing TPM to the entire facility or all machines. It is by identifying one machine. The first would be by either starting with a simple machine that is not key to the production process. However, the other option is by using a critical machine. This method will measure the effectiveness of TPM in the workplace. If the simple machine is chosen, which is less risky, which will mean that it will show less effectiveness as it is not a major machine. It is important to include as many employees within the process as possible. Step 2. Return equipment to the basic condition. Once the pilot has been defined, the next step is for the TPM participants to continuously restore machines to its basic condition using the activities that are outlined in the 5S Foundation. Once this is the normal routine, operators and maintenance staff should begin the autonomous maintenance program, which is where the equipment is cleaned whilst inspecting it for deterioration or abnormalities and eliminating factors that lead to the deterioration of the machine. Step 3. Measure OEE, also known as Overall Equipment Effectiveness. This is essentially measuring how available the equipment is, how it performs, and what kind of quality it produces. If this is done, it will be a very good indicator of whether or not the TPM program is performing, providing the business with data-backed confirmation on whether the efforts to eliminate downtime are working. Step 4. Reduce major losses. This step is carried out by using one of the following pillars of TPM, which is the focus improvement pillar. Once OEE has been measured, the data will be looked, identifying main reasons for the losses that have occurred. After finding the root of the problem, measures can be taken to eliminate these problems if possible. Step 5. Implement planned maintenance. The final stage of applying the TPM program is planning and scheduling maintenance activities. Planned maintenance with a CMS solution that should involve preventive maintenance that allows the machinery to run as planned. There are other pillars that make a successful TPM program. These pillars include such as training and education and new equipment management, which should be carried out continuously as implementation of the program goes on.
Created using Powtoon.